Welcome or welcome back at C Squared. In this lesson we'll talk about congruent figures, and we're gonna talk mostly about congruent triangles. And the first thing I want you to notice here, I said there is a principle of superposition which allows you to use rigid transformation to see congruent figures. We'll see that in the second part of the lesson. But first of all, I want you to take a look to this statement which says two figures are congruent if and only if. This is a very strong statement, biconditional, their corresponding parts are congruent. So let's see what it means. It means very simple. You notice here in the picture we have these two quadrilateral A, B, C, D congruent to E, F, G, H. We have four congruent corresponding sides and four congruent corresponding angle. Let's see them. AB congruent to EF, BC congruent to FG, CD congruent to GH, and the last set of sides AD and HE or EH. Okay, so we have these four corresponding congruent sides, and also angle A congruent to angle E, angle B congruent to angle F, angle C congruent to angle G, and the last one, angle D congruent to angle H. Okay, so if these two quadrilateral are congruent, these 8 parts are congruent. That's one way to see it. And the second way is if the 8 parts are congruent, then the quadrilateral are congruent. That is this big biconditional statement. Now let's take a look to the first example where we have these two quadrilateral M and PQ congruent with SRTV. You don't even have to look to this picture, by the way. You just have to take a look to the statement, and then you can answer to these parts A through F. So let's see A. It says angle N. I want you to take a look. Angle N is right here on the second position. Angle R here is on the second position. So angle N congruent with angle R. Now let's take a look to the next one, which says segment MN. If we take a look, M is on the first position, so we're just gonna go with S, and N on the second, which is gonna go with R. So here I'm gonna say SR. Okay, let's move to the next statement, which says segment MQ. Let's take a look. M goes with S, Q goes with V. So you notice how I select them. So we have here SV. Then let's take a look to D, where it says angle T. Angle T is the third one here. So it's going to match with the third one here, which is angle P. Now on E, we have angle V. Angle V is the last one here. So it's going to match with the last one here, Q. And we have SR. When you notice, this is the reflexive of B. So this is going to be MN, and you can take a look also in the statement. One more time, you don't really need to see the picture. You just look to the statement given to you, and you can match the corresponding parts. Very similar, we have two triangles that are congruent if and only if their corresponding parts are congruent. I said there, that is also known as CPCTC. Corresponding parts of congruent triangles are congruent. And you notice here we have these two triangles are congruent. We have 3 sides, 3 corresponding congruent sides, and 3 corresponding congruent angles. AB congruent with DE, AC congruent with DF, BC, the last one, congruent with EF, and then we have angle A congruent with angle D, angle B, congruent with angle E, and angle C, congruent with angle F. You can use this CPCTC for solving some problems. So again, corresponding parts of congruent triangles are congruent. That is the meaning. Well, let's see this example where we have triangle ABC congruent with triangle ABD, and we need to find the value of the variable, and we notice we have x and y. So let's say we're gonna start with x. If we take a look, x goes with what? With angle C. So the best thing to do is to look to your statement. Angle C match angle D. Angle C congruent with angle D, which means the measure of angle C equals the measure of angle D. And now we can write the equation, which is angle C is 3x plus 1 equals 28. And I'm going to subtract 1. And I have 3x equals 27 divided by 3. X equals 9. Let's take a look to the second part. And let's find y. If you notice, y is this expression that goes with segment BD. And now if we look in here, segment BD goes with segment BC. Segment BD congruent with segment BC, or the measure of BD is the same with the measure of BC. And now we can write the equation, which is 4y minus 7 equals 41. And now we have an equation. We're going to add 7. And we have 4y equals 48 divided by 4 on both sides, obviously. So we have y equals 12. And that's it for this example, where I use the fact that the corresponding part of congruent triangles, these two triangles are congruent. And you see, I match them based on the given statement, not on the picture. Be careful, I will say that. Let's take a look to next example, where you have to identify the triangles that are congruent and write a congruent statement, obviously, and justify your answer. So let's take a look here. What do we have here? Well, in order to prove that these two triangles are congruent, we need to see the 6 parts are congruent. So let's start with what we can see. We can see this side and this side are congruent. They are marked the same. GH, segment GH is congruent with segment VP. The next thing I notice, very similar, we have here 2 marks. Here we have 2 marks. These two are congruent. GF congruent with FP. And let's take a look. We notice also this is 14 and this is 14. That means HF and FV have the same measure, which translate in HF congruent of FV. So we have these 3 corresponding congruent sides. Let's take a look to the angle now. And the first angle I notice is this angle V and angle H. Right, you notice they are marked the same. And let me be consistent. I'm going to start with angle H congruent to angle V. Start with the same triangle. I think it's going to help you better to write the last statement. Then we notice also this angle it's 52 and this angle it's 52. They have the same measure. That means they are congruent also. Angle G congruent to angle P. And you notice I start with the same triangle, the one on the left, FGH. And now we have one more. Are these two angles congruent? And the answer is they are, because these are vertical angles. So I'm gonna write here a congruent statement. I'm gonna use 3 letters to be clear. Angle H, F, G, congruent with angle VFP. So now we see the 6 parts are congruent, 3 corresponding congruent sides and 3 corresponding congruent angles. Then these 2 triangles are congruent. Now, let's take a look how we write this. So I will suggest you to look and start with what you have. In this case, you have this H and G. Obviously, the last one in this statement will be F. Congruent with what triangle? What are the corresponding parts for H and G? V and P. And the last part will be F, right? So you need to be very careful and match the corresponding parts in your last statement when you say the triangle congruent. Of course, this statement here, I think it's also good. Yeah, it works. So there are multiple ways to write the same statement. Be careful. Just be sure you match them correctly. So these are triangle FHG and triangle FVP, right? You notice F goes with F, H goes with V, and G goes with P. Okay, so either one is good. In some cases, triangles share common parts, like in this case you see here. Can we write a congruent statement about these 2 triangles? So you may want to split them aside, or you can keep them like that. Let's see what we get. We notice these 2 sides are congruent. They are marked the same. So we have AC congruent with AD. And then we notice this is 17 and this is 17, which means those 2 sides have the same measure. They are congruent. CB or BC, it really doesn't matter. Congruent with DB, segment DB. And we have one last part. This is the part. I'm gonna mark it like this. Is a common part or common side. So I'm gonna say here AB congruent with itself. AB belongs to both triangles. This is what we call the reflexive property. And now let's take a look to the angles. We notice in the picture angle C, let's start with this one. These 2 angles are congruent. They have the same one arc. But I'm gonna have to write 3 letters. So I'm going to say angle CAB congruent with angle DAB. Now we notice these 2 angles are congruent, and this one we can just name them with 1 letter, angle C congruent with angle D. And also we notice finally these 2 angles are the same. They have the same measure of 62, so they are congruent. Again, we're going to have to use 3 letters. CBA congruent with angle DBA. 6 corresponding congruent parts. So now we can write triangle ABC congruent, and now be careful, you match the corresponding part. AB is the common side, so I'm going to say AB and then D. Okay, so that's it for this example. In all these examples, I said all three corresponding angles were congruent. However, there is a theorem that allows us to move to a different situation. Only two corresponding congruent angle, like in this picture, you see angle A congruent to angle D and angle B congruent to angle E. Even though this picture here and this statement on the right tells us only two corresponding congruent angle, by this third angle theorem we know this angle C should be congruent to angle F, right? Because the sum of the measure of the interior angles is 180 degree. I don't have a proof here, but I will do it and put it on the YouTube channel to see how that works. But this third angle theorem is a very important one in some proofs. So now let's see here, and we have a proof here, which how we prove that these two triangles ABD and ACD are congruent. If you remember, we can do a two-column proof or a flowchart. I'm going to do a two-column proof here. And we have here statements, reasons. And remember, in this moment, in this lesson, in order to prove that these two triangles are congruent, we need to prove that all 6 parts are congruent. Later you'll see we have some shortcuts. So I'm going to start with the first one, right? AB congruent to AC. And you notice that is given to us. Then BD congruent to DC, that is the second part. Again, it's given to us. BD congruent to DC. Okay, so then we have, let's list the side. If you take a look, the third side is this common side. Okay, and by the way, let's mark them on the picture. AB congruent to AC, BD congruent to DC. You may want to do that. And then this is a common side. It belongs to both triangles. AD congruent to itself, AD. That is what we call reflexive property of congruency. Okay, so we have the 3 sides listed. Now let's move to angles. Okay, and now we're going to look to the first angle we see here, angle B congruent to angle C. So let's mark them like this to see it. And this is also given. So we need 2 more angles. And now let's take a look to this segment. What does it say, this one? AD bisect angle BAC. AD bisect this angle, so that means these 2 angles are congruent. Okay, so how I'm going to do that? I'm going to write first AD bisect angle BAC. This is given to us. And based on this statement, I'm gonna say those 2 angles are congruent. Angle BAD congruent to angle CAD. And this is definition of angle bisector. And very similar, we're going to do the last pair of angles. Look here, we have AD bisect angle BDC, so that means these 2 angles, this one and this one, are congruent. So very similar to what we did before. For the last 2 steps, we're going to say AD bisects angle BDC, and this is given to us, right? Then we have angle BDA congruent to angle CDA. Okay, and that's also definition of angle bisector. So now we have 1, 2, 3 sides, 1, 2, 3 angles. We can say triangle ABD congruent of triangle ACD, and the reason will be definition of congruent triangle. Okay, and this is a proof. In this case, you're gonna see in my next lessons, I'll show you how to prove using less parts. But in this moment, see, this is the proof for this problem. And on last part of the lesson, we're gonna take a look to what I said at the beginning. Sometimes you can take a look to triangle congruence, especially in the coordinate grid, look by using rigid transformation. So let's take a look here. Example, we have triangle ABC is congruent with triangle ABD. We know that is given to us. Find a rigid transformation or sometime a series of rigid transformation to justify the triangle congruence. So how can we justify that these two triangles are congruent using a rigid transformation? Notice we have a reflection here of, let's say, triangle ABC over y-axis. If we reflect triangle ABC over the y-axis, then we get triangle ABB. Okay, so simply a reflection here will prove us that these two triangles are congruent. But sometimes you have to look very careful, because it's not just one transformation. You are going to be a series of transformation to prove congruent triangles congruent. So like in this case, I see triangle ABC is congruent to triangle MNP, so I know I have to look to a way to see how can I go from A to M. Okay, and if you say, hey, it might be a translation, right? That's probably the first thing I'll have in my mind. 1, 2, 3, 4, and 2 down, right? Then you want to see if the next set of vertices, like B and N, the other two corresponding, do they follow the same rule? And the answer is not. So, and you can see this is not a translation, right? So what is it? So in this case, sometimes it's kind of hard to see it. These problems generally are multiple choices, in my opinion, from how much I see it. And I think you're gonna have some choices. Look to the choice you have. Okay, and by the way, the answer is not unique. Okay, so I want you to take a look to this picture down here. Okay, so this is the triangle ABC. I reflected over the y-axis, so two transformation, triangle ABC reflected over y-axis. Okay, so you reflect triangle ABC and you get triangle A prime, B prime, C prime, like I call it here. And then you translate by this vector and you get M and P's. And a translation by the vector. We're going what? 1, 2, 3, 4. 4 left, so it's going to be -4 and 2 down. Okay, so this is the series of transformation that allows us to justify that triangle ABC is congruent with triangle MNP. We have a reflection over the y-axis followed by a translation of a vector or a rule. Let me write that also in this way: x minus 4, y minus 2. You may see either way. This is the series of rigid transformation can justify this triangle's congruence. Is this the only one? No. Remember, you can do some other rigid transformation and get the same thing. And the last problem in this lesson is very similar to the other one, and in this case here you're gonna see there are multiple ways to prove triangle's congruence, how I said. Okay, triangle ABC congruent with triangle MNP. So again, you take a look, how can I get from this position of A to this position of M, since this A and M are matched? Okay, and again, translation, yes, but it's not gonna go for all of them, right? Maybe C and I'll say here M and T here, not P. I apologize. Okay, it's gonna be good at translation also for C and T, but that translation is not gonna go for A and N. And here you can see probably a reflection over this line. Oops. If you reflect over this line, right? So option one, I will say here. Option one. It is simply one rigid transformation, reflection over what is the equation of that line? That is y equals positive x, I'm sorry. Okay, so this is an option. Yes, I can reflect triangle ABC over y equals x, and I will map it on top of triangle M and T. But I want you to take a look to this picture. We can do a series of rigid transformation. And what do you notice here? On this one, I rotate triangle ABC 90 degrees. So this is option 2, which has two rigid transformation. Rotation (90°), and you notice we go this way, which is clockwise around origin. Okay, so we can rotate triangle ABC around origin and we get triangle A prime, B prime, C prime, and then what? And then we're gonna do a reflection over x-axis. So these two rigid transformation will allow us to prove that triangle ABC is congruent with triangle MNT. A rotation 90° clockwise and a reflection over the x-axis. And guess what? It can be an option 3, an option 4, and so on. Like I said, these questions most of the time are going to be multiple choice, and you have just to see which one fits your needs. Do one by one and see which one works. If you enjoyed this lesson, Don't forget to click the like button and come back on C-Square for more help. Thank you.